Sorry.
Hi, welcome to the stream, everybody. We're here at SpaceX launch site, and uh, welcome to y'all to the live stream here. We may see a road closure coming up in a half hour, and we have two guests currently, Dr. Caitlin Ahrens of Goddard Space Flight Center, and also another man named Michael. So you're welcome to introduce yourselves, and we'll go from here.
Okay, yeah. I'm I suppose you call like a radio type person who like produces things, but does I do sort of interviews or question and everything, not just politics but science and anything really. So I can see that on a station that's generally known as Channel 107, and I've already spoke to Paul before about his SpaceX project. So the ideas he has, he wants to explore the possibility of finding where more water might exist out there in the solar system, and getting the funding together to get these these projects that where we can explore and find out what we might be able to find about our solar system. Actually, it's one thing that I'm really interested in. It's a good question to ask, which is it's kind of famously known that our Earth has approximately 70% of its water covered, its surface rather covered by water. E.g., a good example of that would be that you can approach, if you were in an alien spacecraft approaching from one side of the planet, if you were approaching on the Pacific Ocean side, it's possible to see nothing but water, just as an example of how much there is. And yet the astonishing fact that I didn't realize about was that apparently there is more water than exists on our Earth elsewhere in the solar system. That the greatest amount of water that exists in our solar system isn't on our planet. So the question would be straight away, out of curiosity, where is all this water actually out there in the solar system?
Absolutely. Well, real quick introduction. Hi, everybody. I'm Dr. Caitlin Ahrens. I work at NASA Goddard Space Flight Center as a postdoctoral research fellow. So I do a lot of planetary geology, but I'm very fascinated in all types of planetary science and astronomy. And I'm also a NASA Solar System ambassador. So you bring up a fantastic starting point to our conversation. Where is all this water? Because you are correct. It's surprising that you see a picture of Earth and it's just this beautiful blue marble, and there's just so much water there. And you look at pictures from Hubble or Voyager or New Horizons, and you see these other moons and planets, and you're like, oh, that looks so pretty, but you don't expect it to be so much water. And so there's this whole scale that we use that kind of gives us a sense of how much water is actually in volume of these different moons and planets and such. So my favorite is just to find household objects around the house. And so it was like a scavenger hunt for me this morning to figure out size and volume to make it very visually appealing, though. So Enceladus and Triton, Triton being Neptune's moon and Enceladus is around Saturn, it has about 0.02 zeta liters. So zeta liter being a 1 with 21 zeros, by the way. So 0.02, it's about the size of this little bead here.
Wow.
So all that water, and you see these beautiful pictures of Enceladus with the water, hot water vapors, just kind of curtain vaporizing up into its atmosphere. So that's only 0.02. Next one is Earth and Pluto. They share approximately about the same percentage of water. So we're going to use this really pretty agate marble here. So between Enceladus and Triton with this little itty bitty bead, and then Earth and Pluto. So we're already kind of getting scaling up. Next with scaling size, we're going to use this Germex bottle here with Europa. So Europa is about 2.6, and then we're going to scale way up now with Callisto, which is about the size of this book. So not everyone really cares about Callisto, unfortunately. Callisto is unfortunately a very ignored moon around Jupiter. And then it really scales up to Titan and Ganymede. So keep in mind that Callisto is about 5 zeta liters. So going from Callisto to this is the biggest thing I could find for Titan. Titan is about the size of this bag here.
Wow.
So much larger water. And then this being Titan, and finally Ganymede being the most amount of water in our entire solar system, is the length of this blanket.
Wow.
So
yeah.
a lot of water at Titan and Ganymede, and certainly a little bit at Callisto. But now the problem, though, is trying to figure out what's inside. What is inside of these gorgeous moons?
Oh yeah, so it's very different, isn't it? So you got Titan, for example. Well, I think it's got methane lakes, for example. So it's very different. If any life is going to be going on around these places, it's going to have adapted very differently. I was going to say to get an idea of how big the zeta is, 21 north. So we've got a system. We've got million with 6, haven't we? Then it goes billion 9. Trillion 12, and then you know what's coming next. It's quadrillion for 4, because tri means 3. For 15. So you're one at 21. We therefore go quadrillion, quintillion, then it's sextillion. So it's sextillion. So that is a huge number. That's what the number is, sextillion. So,
it's quite amazing.
There's a Wikipedia article that says there's at least 20 times more water off Earth than on Earth, and maybe even up to 50 times more water off the planet. Is that true? Is that what you've heard also, Caitlin?
It's quite possible with all those numbers. Absolutely. It's just a matter of how fresh is the water. That is still a very fun mystery that we're trying to figure out.
is it also the case? I was going to say, sorry about that. Is it also the case that it's theorized that the reason we have water on Earth is not because it originated here? We tend to think of things on Earth as maybe originating on Earth, but actually, I think most things that are here have actually been brought to us, including rare metals like gold, for example. It's formed in stars. There's a theory. I don't know whether you kind of go along with it, that the water that we have on this planet has actually come from space. It's possibly because of this.
Absolutely, yes. So the favorite theory, there are many theories, but the favorite theory amongst planetary people, the planetary community, is getting our water from comets, comets and asteroids. So you have comets that are thousands of miles out toward the solar system, and even thousands of miles out past Pluto, and you get all of this rich water ice. And comets are so dynamic to be drawn toward our sun and then zip past and either crash into our Earth, when Earth was just a protoplanet at the time. And it's so fascinating too, is that we're now confirming water on baby stellar formation areas from the Hubble Space Telescope, and then soon James Webb Telescope too. So it's so fascinating to see the dynamics of water at protoplanetary nebula, and then we kind of look backwards in those regions, and we look presently in our solar system and try to make a connection there. So yes, that's the favorite theory, is all this water came from comets. And I know a few people are like, comets, they're rare, like how would that have happened? Well, one, this would have happened thousands to millions of years time span. So we see comets couple dozen in our lifetimes. Some of them are small and far away and everything. But think about this, though, is that our solar system would have been so dynamic early on, so chaotic and so dynamic early on. So we would have had a lot more comets.
I mean, the Earth is 4.3 billion years old, or something like that. I'm not sure if that's exactly right. So I guess that's the time it could have had to gradually bring all that water from space. But it's amazing to think. I mean, the whole Pacific Ocean and everything else, all the other oceans and rivers, etc., all the water that we've got that could be threatened if we go to a runaway global warming situation, which which Venus has got. The theory does say that it has all come from space over time.
Over time.
And as far as that age of the Earth, that is from Western civilization. If we look at the Hindu culture, they have the age of the Earth as many times our accepted version of the history of life here in the universe, and not life, but of the creation of the universe. The Hindu tradition goes back many thousand times, the 4 point whatever billion we're calling the age of our Earth. So they their history says the Earth is much older. Go ahead.
Wow. I was just thinking also is, you're looking for life anywhere, including the most basic format of it that you can get. And sometimes it's in the deepest places within planets and moons, and it's very basic. Is water always essential to that? The presence of water, could it possibly exist without it?
So that's an interesting conversation point, because I have talked to some astrobiologists around the nation, and there's still a debate there. Whether you need hydrogen and oxygen, yes, in some fashion, but whether you combine the hydrogen and oxygen to make water might not necessarily be a big impact as much as we think. And then it kind of goes into, what do we consider to be extremophiles? Can there be extremophiles that absolutely hate oxygen? Yes, those are called methanogens. Methanogens would be lovely on Mars. There's hardly any oxygen on Mars, and so methanogens, these little tiny bits of bacteria that just absolutely love carbon and hydrogen to make methane. And that's why we call them methanogens. And so knowing these different kinds of extremophiles, there's some extremophiles that thrive at Chernobyl still. And they don't necessarily need water in any case to survive either. But there's some extremophiles that prefer water. So having some sort of astrobiology taxonomy maybe something in our future soon enough.
It's interesting to say about Chernobyl, because at first millions of trees died off, but now life has flourished in the in the land that's been mostly abandoned by people. So it just goes to show it that all sorts of conditions can be adapted to. So you've been talking about the solar system. When you define the solar system, this is always interesting about space exploration. Where does it begin and end? When do you stop calling it our solar system and start calling it interstellar space, which is between us and other suns, stars?
Exactly, yes. So having that kind of distinction is also very fun to try to figure out on a map, because our solar system is so humongous, and the answer changes depends upon what type of astronomer you're asking. To a planetary scientist, we get out to the Kuiper Belt, and we kind of go into Oort cloud territory with cometary materials, though, but we pretty much stop at the Oort cloud. But you talk to heliophysics astronomers, and you need to go way past Oort cloud into heliosheath, and then that's their finishing line there. And then anything past how much energy and how much gravity stops around our sun is considered solar system. And then anything past that is interstellar space. So it really does depend upon where you're looking at on the map.
So to get a picture of that, you can use the AU, can't you, which is astronomical units. So simply, it's the distance between the Earth and the Sun. So you're talking that light takes 8 minutes 19 seconds to get from the Sun to here. And then, for a quick idea of scale, the planet, and I'm putting the inverted commas because we don't nobody can really quite decide this, can they? Of Pluto is kind of its orbit's kind of going from varying between 40 and 55 AUs away from the sun. So when you get an idea of how big our solar system is, how far away is that in AU? And I've got another question about the temperature of water to follow this.
Well, as far as AU goes, I unfortunately don't know that at the top of my head. It's one of those things where I typically have to Google very quickly.
But it is a long way out, I think. I think it's
a very long way out.
100. So I'll just ask this, actually. One thing is that the further you go out into the solar system, the lower the temperatures are going to be. Because, you go out as far as Pluto and you will see a slightly bigger white dot, and that is our sun. And it can't provide much warmth and energy at some of the more extreme distances to the edge of the solar system. But there's still a lot of water on some of the outlying moons. It's been discovered. So therefore, is it, how much of this water, therefore, do you think that's out there is frozen rather than the water in the way that we know it?
Well, that's actually part of my research, is dealing with temperatures of different kinds of ice, because it's not just water ice at these outer moons. But for the topic of this talk, we're going to stick with water ice. But the really cool part is that we have something called a frost line, which is where in the solar system does water become liquid to absolutely frozen. And this mark is actually just past the asteroid belt, which is between Mars and Jupiter. So right at Jupiter and beyond, water ice is pretty much frozen at this point. Now, what's considered frozen versus liquid, and this is just on the surface, though. Everything's frozen on the surface. Titan has liquid methane, but still very much hard water ice rock. And then you get all the way out to Pluto, it's still very much rock as water ice. Now, when I mean rock, I don't mean like gravel in your driveway or anything. I mean just at the solid form of water ice, and it lays out the bedrock on Pluto. Now, Pluto, I work in Kelvin at that point with temperature, so Pluto is about 40 Kelvin, which is about negative 400 degrees Fahrenheit. It can get pretty cold on Pluto. And so all of this water ice, the fascinating thing is that we kind of need to run some thermophysical models, yay. And what that means is, how does the water ice bend and move and crack and make geology, make mountains and glaciers and volcanoes on Pluto? And the cool part is that water ice at those very low temperatures act just like volcanic rock here on Earth. The physics are very much similar, which makes the math so much easier. Yay, yay us. But understanding why is still something that we're still researching. But temperatures are not always relevant either. Just because outer solar system is very, very cold, there's spots on the poles of the moon that can get just as cold as Pluto, which is very fascinating. And the moon is certainly closer to the sun than it is to Pluto. But there's still these really deep, dark spots on the moon that can be just as cold, which is so fascinating.
They don't move. That's another thing. So they were more likely to stay in the temperatures. So the dark side stays that way. Mm-hmm. So also, everything's called planets. There's a bunch of rocks that are out there, and they're the ones you can find water, and in the right circumstances you can get life developing on them, like here, but not just here, as we're now finding out with Mars and Titan, etc. But the gas giants, do they have no relationship with water and life because they're just collections of gas, or can you get some life and water forming with gas giants like Jupiter and Saturn rather than just the moons that surround them?
Well, that was an interesting theory at first, because we figure, Venus has certain layers of clouds, and there's like some sweet spot cloud layers of Venus that are like perfect, humid summer weather that we would get here in the States, kind of deal. And we're like, oh, maybe there's a cloud layer on Jupiter or Saturn like that too. But unfortunately, we're finding out that Jupiter and Saturn are just so dynamic, and these humongous storms might be almost too energetic to keep any sort of cloud layer stable enough, very much stable enough to even hold any kind of microbial life. So if early times in its planetary formation may have been a thing, but no, we doubt that there would be any kind of bacteria, anything in the clouds of Jupiter and Saturn. It's just way too dynamic.
Cool. And I've looked at some of on the Wikipedia, it shows the different thicknesses of the ice on the different moons. What is kind of the minimum moon that we know has kind of water or some kind of liquid under the ice? What's the minimum thickness? Because I think Enceladus on the southern area where the tiger stripe cuts on the southern area of Enceladus, it's about 5 miles or less is what I was thinking I was understanding. I think Mars, it's maybe a mile deep. So what's your understanding in that area?
Yes, great question. So it still depends upon what materials you're working with. With Mars, you're dealing with definitely a lot more rock. In this case, the actual term of rock, with basalt, typically with Mars. And so all of that water needs to be deeper, in a sense. Enceladus, you're dealing with a lot of ice. Those tiger stripes, though, is definitely very thin crust. Those tiger stripes are really, really cool, and I encourage everybody to go Google images of tiger stripes on Enceladus. They're very fascinating because how we describe it is that it's almost like the moon is breathing, where the tiger stripes kind of breathe in and out, and when they snap open, there's vapors like geysers that just kind of puff out, and it's really pretty. So I highly encourage you to go check those images out. So thicknesses are still trying to be figured out because we're now figuring, okay, there's a lot of chemistry we're understanding with ice and Enceladus, and even Mars have salt, and salt really, really muddies the water on, well, not just the water, but also our understanding of chemistry. But now we're realizing we need to really better understand the physics too, of ice, and that's actually very difficult to do in a laboratory. But laboratory work in the planetary community is slowly realizing, oh yeah, okay, can we recreate planets and moons in the lab to understand the physics of the ice?
Right. Yeah. And you mentioned Titan. Does Titan have water, or is it just methane? Do we have confirmed water on Titan?
We do have confirmed water on Titan. It's just not liquid, so it is solid. Now, whether it has a liquid mantle is under the category of possible and or dormant. So it may have had an ocean at some point, a very dynamic ocean at some point, but whether it's still active is still under debate and still to be determined. Hopefully, Dragonfly, yay, Dragonfly. So Dragonfly is set to launch in June 2027 from NASA. So Dragonfly is going to be this beautiful quadcopter looking drone that's going to hop around the surface of Titan. So hopefully Dragonfly can give us a better sense of what materials are we looking at too, because it's not just water, ice, and methane on Titan. Titan is a weird anomaly of a moon because there's so many different kinds of ice on the moon. There's acetylene and Acetone, so nail polish remover. Acetone is on Titan as well, and ethane and ethylene, and it's a basket case of chemistry.
That's great. There's some questions here in the chat. I don't know if we want to ask some of these questions now, or one of them is, but if you see the chat, I've been told that the guests in the past can't see the chat and also look at the screen. So if you can't see the chat, I can see the chat and
Yeah,
I can
I
ask some
can't see
questions.
the chat.
Okay. Okay. Yeah, Michael, can you see the chat?
No, I actually don't know where it is on YouTube. So if we can find out what's type into YouTube, sure the people watching know because they're watching it on YouTube, so they know where it is.
If you wanted to go to it, it is the 3 dots in the more area. But I can ask the questions too. Occasionally, I'll throw some in too. So, are you you're already a doctor, right? And you're working at NASA Spaceflight. So you're not working on a thesis anymore. Or are you done with schooling, or what?
Yes, I'm done with schooling. Done with my dissertation. My dissertation was on Pluto.
Okay. I'm seeing. So, are there any missions out there that you're excited about, or that are currently being worked on besides the Titan mission that are going to go out and explore water in our solar system that you know of?
The other outer solar system mission I'm excited about is Europa
Besides
Clipper.
the Titan mission that are going to go out and explore water in our solar system.
Yeah, so Dragonfly is certainly very exciting, but I'm also very excited about Europa Clipper. So another NASA mission. Europa Clipper has been in the works for several years now. It's been underfunded for quite some time, and there's always budget issues. But finally got a launch date, and we finally got a rocket for Europa Clipper to launch in October 2024. So truly around the corner. 2024 for us planetary people is very, very soon. And so we have our instruments getting figured out and built already for Europa Clipper. But it's gonna be a fun ride for the Jupiter system. So we have Europa Clipper coming up. The European Space Agency has the JUICE mission, which is another orbiter around Jupiter, and then Dragonfly. So that's what we have to expect with the outer solar system so far.
Okay, and my last question, my request would be, earlier you were talking about the different planets, and you said past a certain planet, certain things are changing. The temperature on the different planets. I don't know if you can go back and repeat a little bit what you said. It was clear here, it was so much so fast. If you can repeat any of the important stuff that you said when you were talking about the different planets and the, whatever you said there. I liked what I heard, but maybe some of the audience might like to hear it as well. So.
Yeah, absolutely. So temperatures in the solar system are quite fun to deal with. You would think, oh, temperature, yeah, sure. Most states have 4 seasons, whoopee. But we have what's called a frost line. So a frost line is where water typically turns from liquid into solid ice. And this is usually found just outside of the asteroid belt, which is between Mars and Jupiter. So past that line, at Jupiter and beyond, your water is pretty much solid ice. But this is what I'm meaning is that it's only at the surface. Now, there could be some liquid water still in the insides of these moons, which is still to be determined on a lot of them. But on the surface, you start to get colder and colder and colder. And then you start to get to different kinds of ices in the outer solar system too. So Jovian moons, the Galilean moons, Ganymede, Callisto, Europa, and well, we're not going to count Io, have water ice at their surfaces. But then you get into Neptune. Uranus and Neptune moons have a lot of carbon dioxide ice and nitrogen ice. And then you get to Pluto and you have methane ice, nitrogen ice, carbon monoxide ice. And so you start to get into different kinds of ices, and that's where we have our different temperatures, because temperatures around Jupiter, Saturn, nitrogen doesn't solidify that well until you get way into past Uranus. It's very, very fascinating what all the different kinds of ice we can have.
So here's a question. I can put the questions here on screen too, and then Michael, you can take over a little bit. But yeah, so the question is, do you know much about water on the asteroids? From Stephanie asked that question.
Hi, Stephanie. So asteroid, or yes, they may have some like bits and pockets of water, similar to how we would have had water here on Earth. You have cometary material, just kind of, you have a comet coming toward us, the sun or anything, and all the debris getting sublimated off of those comets can land on asteroids. Now, whether it stays on the asteroids, no, not pools of and lagoons of water on asteroids, no. But what Ceres is the dwarf planet in our asteroid belt. Ceres is a gorgeous asteroid. It's a gorgeous dwarf planet. And so would it have some sort of a liquid water, mud, salty ocean at one point? Possibly. Ceres was actually just brought into like the Ocean World's Hall of Fame not too long ago, actually, because now we're realizing, oh, there may have been this kind of muddy, watery substance in the center of Ceres that would have gushed out very slowly onto the surface. And so we consider that to be an ocean world.
Wow. Yeah, Michael, good. I can keep going, but yeah, you go ahead.
Right. Yeah, okay, yeah. There's some interesting ones there. I was thinking about exoplanets, how much we would know about them, and about whether there's different relations with water, but we're talking about the solar system here.
Oh yeah, exoplanets are very, very fascinating and really on the rise of being its own planetary branch within NASA and just within the planetary community in general. And it all goes back to temperatures. Like I said, we have our frost line right at the asteroid belt because also like how our sun produces energy and heat for X amount of distance. And so looking at different stars, if you have much larger stars, that frost line is going to be way out there. But if you have smaller, dimmer stars, that frost line is going to be really close to that host star. And so knowing where those frost lines are around different star types can then give us an idea of, planets near that planet may be more rocky and less icy versus maybe larger and more distant ones.
Well, I was thinking about exoplanets, actually. One thing is that this planet feels quite small because if you think about it, going 20,000 miles and actually coming back isn't all that far, really. And with the population that we have, almost every corner of it we have covered. So you start wondering, are there bigger planets out there that support life like this one and that maybe have 1 million miles on it? But there is a bit of not 20,000, it's that big. But then there is a bit of a problem. It has to orbit around a bigger star, and they don't have as long a life. And also it changes where the habitable zone would be. So if we had such variations in exoplanets, how different do you think it would have to be to get the right conditions to form life with, if we had bigger stars, bigger planets, that sort of thing?
Absolutely. So the exoplanetary community are doing just that right now with just models and models and models. And we have so much data to still comb through because we have the Kepler telescope, we have TESS, which the acronym escapes me right now. And then we have a variety of different techniques to even find these exoplanets too. Different kinds of observing techniques. And then soon, hopefully, the JWST, James Webb Space Telescope, is going to be very helpful for the search for more exoplanets. So that's going to be really exciting for the exoplanetary community. But like you said, we still need to understand the star, and then, like you said, the habitable zone, which we lovingly call, we nicknamed the Goldilocks zone because it's not too hot, not too cold. It's just right for that liquid water, well, to be liquid. So now it gets into what's considered an Earth candidate. And we do have a suspect list on NASA. So if you were to just Google NASA exoplanetary database, we have a full database, and you could actually see a lot of the incoming data that we're getting and all the statistics and numbers, and you can see that suspect list of what's considered to be almost Earth-like in its conditions. Michael, you are on mute.
Yeah, trying to get rid of. I was just trying to get rid of the bin lorry taking part in this show, you know, because that's the job there, is recycling elements, not talking about them. So there's a couple of questions that have come through on the chat, but just before we get into that, to go right back to basics with the concept of exoplanets, just in case there's people listening who are kind of wondering how it works. Just how was it that they were able to make the breakthrough of detecting exoplanets orbiting around distant stars where, you know, it's at such low resolution you can only just about make out the star? How do they work out the detail about that this is a rocky planet, that this one is actually a gas giant, it's 400 Celsius on this one, so this is like a hot hell, but this one might be, and this other one might actually have the right circumstances of life, and they've identified a few of them. How do they know these things? Just how can they tell what type of exoplanets they're observing?
Yes, so the earliest technique that we've had is something called light curves. So light curves are very somewhat easy to tell us how big, the distance of an exoplanet around its host star, and from there you can kind of fill in the blanks. But if you know at least its speed, its size, and distance away from its host star, then you start to get into an idea of, okay, it's this kind of star. Would it be terrestrial like, or would it be icy like? But light curves are interesting. So it's almost like having a power outage with a star. So you're viewing the star, and how a light curve works though is that you get just this very simple line going across your screen. But it's almost like a little blip of power just drains out of that light curve, and so that straight line just goes and then goes back to normal. And so knowing how the length of the dip, how long did that power outage happen, and how fast it happened, there's your planetary stuff that you need. So if it's a very long power outage but maybe very dim, then that can give you a sense of, okay, a big planet but far away, and if it happens very quickly, then it's closer to us versus far away. It's almost like you have to kind of visualize yourself as the observer, and you take an object and you pass it in front of your eyes, kind of deal. You know, is it really big and zips across, or is it very small and very slowly dims the light from your point of view?
Okay,
so it's taking these clues together. Oh, sorry.
Just a quick, can you repeat that? What is that test, or what? Just say once more what that is that shows you that difference.
Yeah, so it's called a light curve, solar light curve.
And
so
what do they measure? Spectroscopy, or what is that? Some type of. Go ahead.
Yes, it measures how much light is being given off of a star. So it doesn't give you power. It doesn't give you much in the way except just illumination. So looking at that curve, light curves also help us if certain stars also are getting brighter or dimmer. There's very certain types of stars that would like pulsate light. Not pulsars; those are a completely different star. But some very large stars that are very unstable would pulsate. So light curves help us figure out like if those are unstable stars. But typically, light curves are very nice and smooth until something passes in front of it, and then the light curve goes down, and
Like
then comes back up.
Yeah, I've heard like a couple planets, and you'll see the flicker, and then you'll know that there's maybe some planets out there somewhere around the star. Is that what you're saying with the?
Yes, and that's just one technique. That's probably the easiest technique we have is light curves. There's also other techniques like actual imaging that we would have through telescopes, but those are really, really, really tiny and very difficult to even find.
It makes you wonder, though, you know, how it can be done just from the little tiny dip in data about the amount of light you're getting back from that star. When you consider the size of planets versus the star, I mean, I'm not sure about the numbers, but we were talking that if you can see the sun as a circle, the Earth would be the smallest dot within it, you can imagine. So, but we're not just talking about a massive view of viewing it from within our own solar system or something. The Earth would be so tiny compared to the sun, it'd be like the smallest pinprick within the sun being the size of, I don't know, something like a beach ball, but it'd be smaller than the size of a human hair within that or something. But then to go out into interstellar space, to be so far away from our solar system and sun and still be able to detect that tiny pinprick within that. How this isn't really using pure photography, but it's using something that looks at the slightest dimming in the amount of light. But how is that even possible to do that?
Yeah, I mean, it is truly amazing how much that technique has helped us even discover exoplanets. And another thing, too, we have to keep in mind is that we're assuming these exoplanets are similar to our own solar system, and that's really not the case. Most exoplanetary systems are just 1 to 3 planets at best. There could be smaller ones, and we
Yeah. Okay, well, you may have, I'm not sure, you may have just lost
she's back. Just a minute. I think
she's back. Yeah. I was going to say we could line up on the next idea. Oh, yes, that's right. You always get something like that happening.
Oh, dear.
Because
oh, dear.
Maybe
so
I pushed something.
so
I don't know. Sorry. Go ahead.
It's all good. Hello, I'm back.
Data amounts for the month. You know, just got to get some more data around. I was going to ask also, what are the, and this is based on the couple of questions that have come in, just check on them again. There's an awful lot to go through, actually, which is, you've got the temperatures in a planet like Venus, which we should look at as being a hostile planet, are ripe for life only in the atmosphere. And you mentioned that before. Can you get conditions for life forming in environments that we find inhospitable like that, or like the surface anyway?
Yes, absolutely. We can even find them here on Earth. So the best example, I don't recall the name because I'm not a biologist and it's a very long biological name, but there are bits and pieces of bacteria that absolutely thrive at the Chernobyl radiation site. They just thrive there. And it's so fascinating to see how something that was a man-made incident create a certain condition of this kind of bacteria. And we find bacteria thriving inside volcanic tubes and even hydrothermal vents at the bottom of the ocean, where you have extreme temperatures and pressures that we humans would not be able to withstand. And then you have certain lakes, especially in Spain. You have lakes that are just so salty, just absolutely salty. And there's bacteria and algae that, again, just grow and thrive with that amount of salt. It's astrobiology is a very fascinating topic, but it's now becoming different in different capacities too, because now we're realizing we need to be careful with astrobiology. So NASA has put out the Planetary Protection Program with NASA.
So
Yeah,
all this is
I know.
oh, sorry, you cut in there. I was going to
I'll
say,
go after
we
you.
first, if you want.
You're good, Michael. Good. I'll go after
Oh,
you.
okay. Well, okay. Yes, you can cut in. We don't know exactly when who should do that. So we're not exactly like the BBC or Channel 5 or something. Oh, actually, we are, because they do cut over each other. The whole reason you know about all of this is because of the equipment that you send out, which has gone to the outer reach of the solar system over a long time. But how much time do you need to devote to sending out this equipment because of the vast timescales of travel in the solar system? If you want to go and photograph the moons of Jupiter, for example, just how long does it take for all that, for the remote cameras to even get there?
Yes, so this is I'll give you guys a little bit behind the scenes of how planetary missions work. So first you need to write a specific proposal. Wherever you're going to end up in the solar system, there's different tiers, different tier levels of NASA that you would apply for. So say you want to, take a camera, take a probe out to Jupiter. So you have to wait for a certain tier of funding that NASA will allow folks to go like, hey, we're looking for proposals in this tier to do science, put in your proposals. And so those teams, those planetary mission teams, take a minimum 2 years just to write the proposal. Minimum 2 years just to write the proposal for at least Jupiter and beyond, for that kind of proposal. And then it, again, depends upon where in the solar system you want to go. You would have to figure out what's called your launch window. Your launch window has to match your trajectory, because if you have just a limited amount of time to get to your point B, you need to either really hurry up or you take your time. And maybe not with much delay. So, for example, we really want a mission to Neptune, and unfortunately, our window of opportunity to have a trajectory to Neptune is going away very, very quickly. But for Jupiter, thankfully, closer than Uranus and Neptune system. So that window of opportunity, okay, you find your trajectory, you figure out your launch window, and then all that time in between, you would need to develop your instruments. And we have what's called the technical readiness level, or TRLs. What we love to do is recycle instruments. If we already have a blueprint for a specific camera, we're like, oh yeah, that camera worked great on Mars. Let's put it at Jupiter. We already have the blueprint for that camera for Mars, and we just build it again and try to keep it for Jupiter. So we recycle our blueprints a lot with certain instruments, and that's actually what we did with Juno. The camera system on Juno takes the beautiful stormy Jupiter pictures as designed off of the HiRISE camera going around Mars on the Mars Reconnaissance Orbiter. So we recycle at least blueprints and materials sometimes too. So getting all those instruments ready, getting your science team ready. What kind of science do you want to do with these cameras? What other instruments do you want? If you know you're going to go around some of the moons of Jupiter, it's really nice to have a magnetometer. Magnetometers are really good for figuring out like the pulses, the heartbeats of moons, and like magnetic fields. A bunch of magnetic fields around Jupiter that we still don't understand, and radiation. And so do you want radio signals, and you need to figure out your comm links. So like I said, minimum 2 years just to even write the proposal, and then the rest of your time is either you're just like working like crazy. Funding can also go up and down. Europa Clipper had some delay issues with some of their instruments, so that launch window kind of got pushed back. Dragonfly had a delay through the pandemic, so it got bumped. Its launch date got bumped up by a year, and hopefully no more than that. So it's very entertaining to see how missions are planned out. And there's actually a book that I highly recommend. It's written by the Europa Clipper team, and it's a really long title. Let's see if I can make sure though, but I highly recommend this book. It's The Mission. And then the rest of this is just a one long title though, but by David Brown. It goes through the ins and outs of the Europa Clipper mission and how the planning worked. So it's a very fun book. Highly recommend it.
This is quite a unique question that I've seen from the chat from I Am You, which is just getting that back up now. It's even the alien extremophile, which you've been mentioning, especially the ones adapting to life around Chernobyl, had such differing physiology to us as the example that you mentioned that oxygen could kill. Would we recognize that as life?
Yes, absolutely. So there are astrobiologists that are considering different kinds of life, and there's again different tiers of what do we consider life. If there's any kind of like little tiny bacteria, yeah, absolutely, that is considered life. So we are carbon-based life forms, but there could very well be silicate-based that may not have that much carbon in their system. But silicate-based life forms are a theory. There's also that's the popular one that I've heard is silicate-based. So silica of silicone compound element, if you will. So yeah, those are very interesting to figure out. Like, do we consider that life? Absolutely, because it's something that is not of rock and mineral, but it's something of an organic origin of some sort.
There's dark matter as well. I mean, you want to take this to the idea to extremes. You could have carbon-based life forms could exist within dark matter. Apparently, it's kind of like everything's slightly mirrored. If dark matter comes into contact with, well, non-dark matter, that's us, that's the Earth, etc., there will be a violent reaction. So that would still be considered life, wouldn't it? And everything existing in dark matter, but in the same forms that we have now. If you kind of follow that.
Yeah, absolutely. It's just a matter of observing it. So there may very well be life everywhere, but it's still a matter of detecting it too. And then that kind of gets into more of like the radio astronomy versus astrophysics fields of astronomy, and that's some people's jobs too. And the best place that is looking into that specifically is the SETI Institute out in California.
Okay, I have to interrupt here and say I agree with that statement that there is life everywhere. And the real trick from my perspective as a meditator, in my meditative experience, the trick is to find something that's not alive from a meditative experience. So go ahead. Thank you very much.
I was going to say also that just get this straight now. Just to answer the question about the overexposed webcam that's just come in, is that it's not exactly TV standard. It's just a Hewlett Packard £10 webcam, and the sun is shining straight into the window, which is something I had to order for. It was making something. It was putting sunlight over equipment. So The sun is a very powerful force. Absolutely. So, could life thrive? Oh, we've done this one, haven't we? In a situation, such as Venus's. The temperature of Venus is ridiculous, isn't it? It's a runaway global warming situation, actually, so it's something we should worry about, because the surface temperature there is usually over 450 Celsius. Does life ever thrive in these extreme temperatures?
Possibly. So Venus, I kind of gave us a bit of a scare, an excitement, maybe I should say. I kind of give us a bit of an anxiety attack, if anything. Last year, we may have detected something called phosphine. So phosphine is, to astrobiologists, almost like a small building block toward any kind of organic bacterial life. And so there's this huge debate now as to, like, wait, did we actually detect phosphine, or was it noise from the instrument? And some people couldn't find phosphine again. And so now people are kind of starting to gear up toward, like, well, maybe it's still there and we just caught it at a bad time and it's only there in like tendrils instead of like a giant thick cloud layer. So the hunt for phosphine is now going on with the Venus community. But thankfully, this whole phosphine debate happened, like I said, very early, mid 2020. Just fairly recently, only within the past about 3 months ago now, NASA has made its decision to have 2 Venus missions for its new discovery program. So it's very exciting that we have Veritas and Da Vinci. And then the European Space Agency, just a couple of days after that announcement, just announced their Envision Venus program as well. So we have 3 Venus missions at the get-go, confirmed, going to Venus. Now, are they specifically going to look for phosphine? No. But are they going to look at the chemistry of the clouds on the surface? Yes. So if anything, it can sidestep and maybe look toward phosphine, but it's not its primary objectives. We really need to understand how do the clouds and atmosphere work on Venus. And then the surface is weird too. Venus is just weird in general, and it's a beautiful planet. But yeah, there's a lot of mystery wrapped in a planet.
You could use it to cook anything if you were in the atmosphere and then send something down. Well, so is there any way that this liquid, we're talking about the water, that might exist, or definitely does, in fact, was kind of proven over some of these moons and in all these locations within the solar system? Now, of course, it's vast on Earth, isn't it? So, you got the size of oceans. Has it been shown on camera, or is it kind of in too small a quantity or too small a space to sort of be shown on camera in vision?
Yeah, so are we talking about like outer planet moons then?
Well, yes, any of the water that's been discovered anywhere. Has it been enough to actually show a picture of it, or is it just an identification of very small quantities that to be water that would be too small to see visually?
So I'm going to go with yes and no. So we do know that surfaces, just very large surfaces of these moons, and even small moons, have water ice, and we confirm it with something called a spectrometer, which is what I like to call the chemistry camera. So spectrometers take a picture, but not in the sense of you see a visualization, but instead takes a picture, and it's just a bunch of lines. But each of those lines can tell us, like, okay, there's hydrogen, there's oxygen, there's carbon, there's silica, and so on and so forth. So water ice has a very specific peak in all those lines that we have to really look forward to. And if you see a bunch of these over the years, you really kind of hone in on, like, oh, yep, there's water ice, there's methane. Methane has a specific pattern. Water ice has a specific pattern. nitrogen is boring, and carbon dioxide and carbon monoxide ices have their own specific signature. So it's almost like finding a fingerprint of water ice at these moons and planets. You got to find the right fingerprint match at each of these moons. And so just surface wise, we confirm most, if not all, of these moons have water ice on their surface. But the inside of these moons, that's where the trouble comes in. A lot of the volume inside of these moons is still very theoretical. So let's take Ganymede, for example, how thick its mantle would have been and how deep its ocean would have been, and thickness variations and whatnot. That's still very much theoretical because it doesn't have geysers on Ganymede. So we can't say that it's an active ocean world. We can only guess based on how the surface has been formed over the years. And when I mean over the years, I don't mean like, oh, just last year or anything. No, I mean like in a span of thousands to millions of years. And so looking at like how our craters formed and how our fault systems all over Ganymede. There's like light terrain versus dark terrain, and the dark terrain has a bunch of craters, so we know that those the oldest terrain, and resurfacing with the lighter terrain. So Ganymede having that huge amount of volume compared to Earth. I'll bring up size comparison again though, but Ganymede's volume of water is the length of this blanket versus Earth. So volume of water wise. And so all of this theoretical work is still being worked on.
Okay, maybe can you tell us where Ganymede is in relation to Earth and how long it would take to get there? Kind of like a synopsis. If we did a mission tomorrow, how long would it take to get to Ganymede using our current technology? You know. With that, say also.
So
let's put a camera on that. If we were to, so what I see is we got the Mars rover. We go to Mars. We move around the Mars with the rover, and we take some photos. So my passion with Ocean Cam is to go to one of these planets and actually take a picture, but more than a picture, to take a video from the liquid. We get to the liquid, take a video, whether it's live or we do like I don't know, a 20-minute recording, and then we send it back to us. Or maybe we have something in orbit over the moon. I think Elon's talking about putting different Starlinks around, maybe around Mars and some of these other moons. So Starlink is called Starlink, and maybe he's planning to do it around these different planets and stars and things like that, and moons. Yeah. So if we were to take like the on Earth, there's something called explore.org, and they have ocean cameras here in the ocean, and there's also Nautilus, and I'm sure there's other organizations who already stream from the ocean here. So if we could, what I'm envisioning is if we can get the people who already stream from the ocean here, get their technology with the people who are doing the Mars rover stuff and figure out a trajectory, we can maybe send something to one of these places where we know there's liquid water, and then we can move forward and kind of change our history on a planet, knowing that we've seen the water, everybody gets excited about seeing the water, and maybe more people are interested in space. So that's my vision.
I mean, that would be really cool. My best bet would be with Europa, and then hopefully with Enceladus. Enceladus is way more active, but the problem with Enceladus is that you're also farther away. So if you were to go to Jupiter with our current technology, if it was light, it was a very lightweight mission, probably 5 years maximum with our current technology. If you were really wanting to go fast, I bet you could push for 4. But it would probably be closer to 5. Saturn can take at least up to 7 years. But again, it depends upon how much instruments are you putting on here. Typically, instruments don't, as far as NASA goes, aren't just cameras. You also have your comm links and accelerometers, and make sure like your health check system of your whole package. But if it's just cameras, that's one thing. But if you can have like a spectrometer to confirm water ice or different kinds of chemistries, that appeals to a lot of people too, as like a verification. Pictures can only give you so much. So having some sort of spectrometer would be really nice. Magnetometers are also really good for understanding magnetic fields, and magnetic fields can also make or break oceans, and how turbulent oceans can be. We got to understand magnetic fields around larger planets. So having just those small instruments, and our technology can make cameras and magnetometers and everything like that so small. So it's not any stretch of the imagination to have a lightweight mission. Time frame though, yeah, I'd say, and if your trajectory is just right too, because if you say you want to go to Jupiter, but you really want to be there in less than 4 years, you're going to need to do some serious like swing with Venus. Mars we don't typically use that much for Jupiter, but Venus is a really good planet for you go to Venus and you let Venus just kind of take gravity, hold you, and just kind of slingshot you to Jupiter if you want to make good time.
So we haven't actually had people actually go anywhere further than, say, I assume it's the International Space Station, or sort of near space, since the Apollo moon missions. And there's been quite a lot of talk about how we're going to not just be sending equipment, but there's actually a potential of people going actually as far as Mars. Is that still a possible reality that's being planned, or is it actually still? Is it going to just remain sending technology remotely, cameras and spectrometers and all of this equipment, or are we going to actually see people possibly going to visit Mars?
So it is still a possibility to send people to Mars, but it's not as quick as people may think. So we have the Artemis missions at the ready. So we have Artemis 1, 2, and 3. So Artemis is essentially going to be the Apollo program 2.0. So Artemis 1 is set to launch, I believe, in 2022 or 2023. That's going to be kind of our dress rehearsal. It'll be uncrewed. Artemis 2 will be our first crewed mission back to the moon after 40 plus years now at this point. 45 plus years at this point. We haven't been back to the moon in a while. But we want to essentially make sure we can get back to the moon correctly, safely, using our current technology. Is it going to be like, oh yeah, our technology has been much improved since the 1970s? Yeah, that'll be fine. But let the moon be kind of our dress rehearsal, our base, to make sure that we did it correctly. What instruments, what can we change and make it better? And then use the moon as a stepping stone to then go to Mars. And there's still a lot of bits and problems about Mars that we're trying to figure out, especially with spacesuits. So spacesuits are very important right now in designing to handle Mars, because all that dust on Mars can get stuck everywhere. It's like a really bad day at the beach. Sand is just cling onto you, and that's very, very hazardous for future astronauts. So spacesuit design is well underway to get us to Mars.
And the time scale is something like 6 months, or is it longer than that? So, I mean, the question has been, that's one question, but you might not be able to answer this very easily. You might not know, but everybody wonders that why it stopped in the 70s and there was no more space visits through the 80s, 90s, noughties, and 10s. And it's taken up to this point for the talk to start about, well, let's see about, if we can actually get people to Mars. Why was there such a big gap from the 70s? If it went on so much through those Apollo missions, why did it stop there?
Yeah, it's all in the matter of funding at this point. So it's funding pretty much shifted. So unfortunately, politics got in the way of science. But also during the 80s, we were still receiving beautiful, beautiful data and images from the Voyager 1 and 2 missions. So that kind of satiated our thirst for the outer solar system. But to tell you the truth, though, many missions were being proposed to Congress and the National Academy of Sciences well throughout the 80s. It was just a matter of no one got funding, no one got approved to have these. So look at New Horizons with Pluto. It finally got off the ground and got to Pluto in 2015, summer of 2015. Wow, that was so long ago now. Oh, goodness gracious. But originally it was proposed in the late 80s. It just took a lot of effort to finally get the proposal perfect enough for it to be accepted as a mission, get the instruments built and ready, get the spacecraft ready, and then get through that trajectory. And it took 9.5 years to even get to Pluto. So it's all in the matter of your timing and your funding, truly. So a bunch of Mars missions were also proposed in the early 90s, and none of them got funded. Hubble Space Program, thankfully, happened in 92, so that really helped a new boom of astronomy with all the really pretty pictures and everything. That really helped. But yeah, there was a bit of a lull, and hopefully, I'd say since 2015, there's been a nice grow of smaller but vast planetary missions.
Because that just fed into the conspiracy theories about, you know, whether we even went there in the first place. And it's often cited actually not just the reasons that they have, but about the time it's taken to. It's not just continued, so it's just a matter of funding. But you also had just over there in the States, you've just come out of the Donald Trump administration. You said you couldn't get funding through what was obviously the same through the Reagan and the Bill Clinton administration and so on. What was it like with the Donald Trump administration? How did they view the work of NASA?
Hey, Michael, I'd like to get that question. Let's not go into politics, but I do have a couple questions also, unless you have something else you'd like to go into.
I think there is. Yeah, See, I wondered that actually, whether you would not be able to comment on that at all. Actually, it couldn't have changed that much though, because a lot of things were and are going on. And I'm just trying to remember what I had next actually, because I did have something next.
I've got a couple questions.
Yeah, I think Paul has some questions.
I'll think of that whilst Paul comes back.
Thanks, Mike. So yeah, I know to go to Mercury, even though it's one of our closest planets, it took us a while to get there because of the trajectory and everything. If we were based on the current missions out there, what would be the next what mission is out there? What's the closest one where if a miracle happened, we can get a video camera on it and we might get some interesting ocean or water shots?
Oh, if we were to approve a mission to this day.
No, if a mission that's already approved and being worked on, but if they got an injection of like $3 billion, we could get a video camera on it and make that mission happen. Additional equipment.
Okay, well, because I was about to say Europa Clipper is probably the closest one, but unfortunately their instruments are already set in stone. And they had budgetary issues, so we've actually had to drop instruments with Europa Clipper and then add cheaper versions back on, and it was a mess. It was an absolute mess.
Okay. And what year? What year is that mission, the Europa one? What's the background on that timing? What's the timing?
It's going to launch in late 2024.
24. Okay.
Yes,
okay.
But it's been planned since way before 2015. Because I've known about Clipper since, well into 2013, 2014. So who knows when it would have actually really started as far, because again, proposals take a while, funding takes a while, getting instruments takes a while. But there are, I highly encourage you to look at the different tier levels that NASA provides as far as what we call the AO, or announcement of opportunity. So every time you hear AO, it means that there's a round of proposals to be ready, and there's different levels, depends upon the budget that you would want your mission to happen. So small, easy, quick missions are something called simplex, and I don't remember the acronym, but SIMPLEX. Simplex is quick and short, to the point missions, nice cheap options, but those are somewhat closer to Earth. So I bet you can do a simplex mission to the Jupiter system. I don't really remember the cap, the amount cap of each of these tiers though. But simplex is your simple but quick science, and then you get into your discovery programs and new frontiers programs, and so on.
Okay. I changed the video here because we have a GSE tank coming down around the corner up there. So that's why I put it in the center of the screen here. But we'll keep going. I think we can go another, maybe another 15 minutes and see how we're doing, everybody, and check in together. But yeah, go ahead.
I've got a slightly more unusual one, but again, it feeds into the thinking about wondering about the effects of the first visits to the moon from 1969 onwards, which is things were left there actually, which is interesting. So the condition of the things that were left there, which is possibly a flag, I'm not quite sure, would tell you a little bit about what sort of an environment the moon is. So say I've often wondered this, and maybe wouldn't be alone in it. Say the American flag was left, and you go back there in 2020 something. Is the moon such a brutal environment with no filters for cosmic radiation, the pure light of the the pure white light of the sun hitting it? Would the flag be completely faded? Would it possibly damage things that are left on the moon? Would there be anything left that you'd be able to see by then as evidence of the first visits?
So yes and no. So the flag would be faded. The colors would be turned white. But as far as other instances like footprints, since there's no wind on the moon, footprints are and rover tracks would still be on there, because the moon is not that active, much like the Earth, where you have earthquakes and volcanoes and oceans to and weather and erosion to wipe away a lot of that kind of evidence. You walk on the beach and you leave footprints behind. The ocean is going to wipe away your footprints. On the moon, there's no oceans. There's solar weathering, but not in the sense of wiping away footprints. So when you go there, if we were to go back to any of the Apollo sites, which we don't really have in the books right now, because we want to explore the southern pole of the moon, it's interesting is that what equipment is still there, some of it is actually still working, barely, but still working, and or at least set up properly that we can still do stuff with it here on Earth. And footprints would still, and rover tracks would still be there on the moon, but the flag, and then there were a couple pictures left on the moon as well. Those would be faded as well from all the sun exposure.
Well, I've made a word for this. I call it photochromodegradation. I assume it's the same thing, but more intense, which is when you leave, say, your favorite books or DVD covers or paintings, you get the sunlight coming in and you lose, particularly the red and yellow end of the spectrum is affected more than blue, I've seen. Oh, you see some business signs outside or road signs, you see all that, and you lose the red, it comes a pink, and you particularly, I find yellow is the one that really gets lost. So I assume that that you're getting a right blast of this unfiltered, UV everything. It's UV, ultraviolet light, that particularly does this damage, isn't it? So I assume that the moon is absolutely peppered by that, by the sun, isn't it? So
yeah, and it's not just ultraviolet light you have to deal with on the moon too, because there's no atmosphere on the moon. You're also dealing with X-rays and gamma rays. So very dangerous radiations for our astronauts.
So yes, wondering if that was going to be left there. Now, in terms of it, there won't be a revisit to the actual spot on the moon, you say, to try and where the original Apollo missions kind of went and left these things. Yeah, you've got the very powerful photography telescopes and such. Can it be observed? Can these objects be observed from Earth, even though they are obviously so incredibly tiny to see from here? Is that or is that just impossible? Or could they see to that detail on the moon to actually spot these things from Earth?
So, to my knowledge, using very, very powerful telescopes, and when I mean powerful, I mean large telescopes, you could possibly pick up the reflecting mirrors left by the later Apollo missions. But as far as like distinguishing the flag and rovers and everything, no. To my knowledge, though. But there are powerful cameras on the Lunar Reconnaissance Orbiter still going around the moon right now, and those can give us a nice daily look at, like, okay, here's this Apollo site, here's this Apollo site, what was left behind. So we still have that kind of monitoring system, and currently in the lunar community, that's still a debate as to if we were to go to the equatorial region of the moon, would we go back to a historic site as far as just preservation and pick up where we left off, or do we just go somewhere new? And that's a really fun debate amongst the lunar planetary science community people. Is do we go back and almost archive and do that over again with newer technology, or do we just go explore somewhere new? But right now we're focusing on the South Pole of the moon for future exploration currently.
I've just lost a question I was going to ask from the chat that somebody had. I'll try and find that. It's gone up my head. I'll copy and paste it or something. But I was going to go close to the Earth for this last question, which is where we've done the most exploring. We've got the International Space Station. We've done so many things there that we've now got this problem of space debris, and that's truly scary. It's not like a few things left over that, they're in space, they are whizzing around because they're in orbit and they're traveling at immense speeds. I think is something like not sure of the exact speed, but we're talking ridiculous 10,000 miles an hour or something, or maybe several thousand miles an hour. It could destroy a satellite if it was in the wrong place. I wondered with some of the things that NASA's been doing around the Earth, have you encountered problems with space debris causing damage and being a hazard to anybody that is living and working for periods of up to 6 months in the International Space Station, etc.?
It is still definitely a hazard. Anything of large shape, size, mass. Thankfully, we have a lot of monitors around the globe. A lot of international collaboration to verify trajectories and where certain objects are. So thankfully not something like a B-rated sci-fi movie where it's just like, we got 8 minutes till an asteroid's gonna hit. It's like, no, we would know much farther in advance, thankfully. But with the International Space Station, yes, it's still very much a hazard with very small, but like you said, incredibly fast, very fast particles. And so having that kind of monitor system is still very much a hazard. It's very much a risk. But the probability, however, is still low. It's never zero, but it's considered low. If anything, the most trouble they would have is solar storms, where you're not dealing with fast particles, but you're dealing with dangerous, energetic particles that can go right through their metal and basically right through their bone too on the space station. So that's terrifying, is how powerful our sun is.
And they create, that's the same phenomenon that creates the northern lights, isn't it? The solar winds, and they can mess up our electromagnetism on Earth, and cause trouble with the communications, the pylons, all sorts of things. Yep. So a lot of people are asking about, and let's just check this out, if missions are going to be collecting water samples to bring it back to study them. So from these various outer moons, etc., it might be gathered from. So are there plans to bring it back as well?
Yes and no. The problem, though, is how do you collect data without really interfering with it. Which, I'm sure most folks who are listening in are thinking like, oh, just use a straw and suck up the water. It'll be fine. But no, we have the Planetary Protection System, Planetary Protection Program out of NASA to consider here. It's a huge no-no to just go in and go like, oh, here's some water, let's bring it back. No, we have to be very, very careful on how sanitary we can be. Because what if there is tiny bits of bacteria in those oceans? We want to be very careful that we're not going to immediately pollute those outer solar system oceans. And so collecting it, how are we going to collect it? How are we going to do it as sanitary and carefully as possible? And then what kind of sanitary containment system can survive the way back? So getting those kind of samples is going to be very tricky. Are we ignoring it? No, absolutely not. Do we want to? Absolutely, yes. But right now, it's forming that kind of technology. We can't just go like, oh, grab a shovel and a pail and let's go. No, so developing those technologies is what's currently going on now. Especially sanitary conditions. So that's a whole branch of NASA that was just formed truly just a couple years ago. I say a couple, and then time has flown so much I even forget that it's 2021 at times. So a few years, meaning at least less than 10 years. But that program is very, very specific to make sure we do not contaminate other moons and planets, and make sure that we're being cautious when we bring samples back. How are we cautious in the lab and make sure we don't end up like a bad sci-fi movie and contaminate ourselves?
We've hardly got an unblemished record right here on Earth, have we, for keeping things as they should be, as we've seen from some of the climactic events that have been going on. But now to go to a question that's just come in from Speedrunner G55, which is, are there any plans for the nuclear-powered sub to explore the subsurface oceans on Europa, on that moon? I forget. He said he forgets what the original mission was called that did that.
So space submarines, as awesome as that would be, again, back to planetary protection programs, now we're realizing, would some sort of thermal radiation that would be used for a battery? We absolutely need to use that thermonuclear as a battery source. Would that essentially contaminate the ocean? So that's being tested currently as well too. But to just slap it on a rocket and go, let's go, no, we're not ready for that yet. It would be really, really cool, but no, we're nowhere ready for that bit. So the closest thing that you could probably do to get to even remotely to the surface carefully and cautiously would be some sort of like little cube sats that you can just onto the surface.
And now for something you were going to consider probably cheesy, or it was a genuine debate, though. Obviously, people of millennial age grew up thinking about 9 planets and counting Pluto as one. Then they thought, oh, there's all these other ones around that are quite similar size. We haven't really discovered them, and that could be a 10th, but that could be a 38th over there, and so on. And oh, that's not a planet anymore. Pluto, it's just like that, it's a dwarf one. And then they sort of go and change their minds. Do you have like a personal take on that, of how you'd like to think of Pluto?
So I have 2 trains of thought going on with Pluto. One, I also grew up with Pluto being a planet. I think it's a planet. But my main philosophy though is that Pluto is just going to keep going around the sun regardless, and so Pluto doesn't even know its own name. So scientists love to put labels on things, but in the grand scale of nature, Pluto's going to Pluto.
So whether you call it a dwarf one or not, there's so many of these, aren't there? That's the thing. And before you get to, is it the Oort cloud? It's before that, everything's broken up into sort of icy rocks and things.
Yeah, well, Pluto's with the Kuiper Belt, and then it goes in the Oort cloud. So again, it's all labels.
Kuiper Belt, then the Oort cloud. Is that the Oort cloud? We talked about the size of the solar system before. Is that kind of the furthest out things that you can identify as being part of our solar system? But there's things further, aren't there?
Yes, so the Oort cloud. So it's interesting. We always see like the beautiful posters in schools, or if you were to Google like educational resources, you kind of see this almost linear. Here's the planets. There's Pluto, and here's Kuiper Belt, and here's Oort cloud. It almost looks sort of linear, but looking at a 3D view of this, all the planets are spinning on the same playing field. A little bit of tilt here and there, but they're all pretty much on the same playing field. When you get into Kuiper Belt and Oort cloud, it's a sphere around our sun. All of these cometary materials. It's not a disk. It's a orb circling our sun, and it looks really, really cool. Now it's not thick. It's not a dense cloud per se, but it's just all of this cometary material that would just kind of bump into each other and snowball, and then you got your comet. It feels the gravitational force of our sun, and there's your comet.
So if you aim the right way, actually, and go into interstellar space, and the nearest place we could go to, but it would take an immense amount of time, is the Alpha Centauri. There's actually 2 stars, isn't there? I wonder how many places that exoplanets might exist where there are 2 stars, and maybe you don't get the day and night. Maybe you get a situation where the light is constantly on the planet and things like that.
Absolutely. So, exoplanets in that term and dynamics. Yep, there are exoplanetary scientists that are specifically looking at that very question.
Which is, that things get also denser, don't they, as well, when we get towards the center of the galaxy, and the amount of stars. So I imagine I wonder if that far away, or in these places that are in such dense star systems, and there are higher pressures, things are more intense. Could life develop in places like that? Because I can imagine that it would be a sort of permanent daylight there as well, because there are so many stars offering faint light but closer by, in places that are closer to the center of the galaxy. Do you think life could exist in those places?
I am very, very possible, because I think of it this way, though, is that could life be just in the subsurface instead? And it wouldn't matter one way or another if it did get 24-hour light or not. So then it gets into what types of planets can be formed. Do you have something that's so metal rich of planets with such very dense stars? You would have a lot of metal around, metal stars, or do you have icy worlds, in which case go to the oceans, there's less radiation there, but it could be warm, very warm oceans in those moons. And Paul just got back in the view. Hello again, Paul.
Hey everybody. So we're at 1 hour and 30 minutes. I want to ask one more question myself, but maybe we'll wrap it up a little bit, unless you want to go a lot longer.
Well, I've got one thought of a final one. I don't know, it could be quite quick, but if you want to go in with something now.
Yeah, okay. Yeah, okay. So, what spurs the collaboration between the different space organizations and maybe the different businesses here on Earth? How do they currently work together, or how can they in the future? Or if anyone has a business and they'd like to get involved with the space kind of stuff, I guess if they come up with a certain a beneficial technology, the different corporations will consider adding it to their space program or something like that. But how do the different space organizations here on Earth interact with each other, like the Indian Space Organization, maybe the China one, and NASA, and maybe SpaceX here? How do you see that they work together? How could they potentially work together? And the last question would be, if there were like $5 quadrillion available, and kind of a make-believe or kind of a fun question, if we had unlimited cash, like $5 quadrillion, that's like many, many trillions of dollars, And we wanted to, if everybody here on Earth was excited about going to space, and somehow we had a lot of manufacturing available, maybe if something became available, what could we do, or what would be kind of an interesting mission that we could do if we had that amount of money?
All right, interesting questions. So I'll answer the first one, where collaborations. Yes, so collaborations are very, very dynamic. Never a dull day at work for a lot of us NASA folk, because we're constantly chatting with each other. There's always ideas. Whether news media is just like, oh, NASA did this and NASA did that, and maybe it's a slow news day. In behind the curtain, we're in constant chat mode. So I chat with a lot of colleagues internationally, and they work with different space agencies, and it's still very much privacy privacy policies that we would need to have in place. But what's interesting, though, is that there's a lot of smaller space agencies that are coming up through the ranks, and doing different stuff too. So we no longer feel hardcore competitive anymore, like back in the 60s and 70s. But now it's a matter of like, oh, we specialize in this, and if we wanted a mission like that, we would have that collaboration at the ready and go like, oh, you guys know such and such better than we do. So take, for example, Venus. The U.S. has never landed on Venus, but guess who the prime space agency was that landed on Venus multiple times? It was the Soviet Union. And now their space agency is called Roscosmos. And so Roscosmos is very, very helpful in helping us design our Da Vinci and Veritas missions, and also the German space agency called the DLR, DLRE. DLRE, it works with the European Space Agency. The European Space Agency helped a lot with the United Arab Emirates with their HOPE Mars mission as well. And so we're starting to get a bunch of different collaborations, and it's absolutely fascinating. And then congratulations to the Chinese with their recent lunar and Mars missions as well. We have the Canadian Space Agency that's really taking a rise in understanding the medical science with astronauts. So that's a whole new branch of planetary science mixing with medical science now, and the Canadians are leading in that. So all these collaborations, it truly boils down to who has the idea, and then it just kind of starts branching out into who can do it. Who can do what? Who could be the facilitator? Who can build the rocket? Who can build the payloads? It's easier if different international partners sponsor or build an instrument to then put on a nice, neatly wrapped package, a payload, and then put it on a rocket and up you go. So again, there's some privacy that.
I just lost her again. Actually, I was going to, if she comes back on, which you do get internet problems.
Get back on.
Yeah, well, I was going to ask. I don't know what you
Here
think.
she is.
Oh, there you go. You get that?
Okay. Just a minute. See if we're good. Let me see. She's here in the chat. Let me zoom out. Just a minute.
I was thinking, actually, is the one thing, and it would be good conclusionary one. I don't know if you'd agree with this, which is about
Dr. Caitlin. Just a minute. Go ahead. Just a minute. Okay, here we go.
Yeah, there you go.
Hello.
Thank you for coming back. It may be something here on my end with the signal too, so I'm not sure, but you're welcome to be here, and we're good.
But in quick answer to your last question though was if we had so much money, what would we do? I truly think oceans are so mysterious, and so if we had the sanitary conditions, the sanitary technology, and just send like a little mini submarine down to these oceans. That would be awesome. That would be so awesome. Which moon would we do? Oh goodness, Enceladus would be cool because it's very active. We see these geysers. It would be a good entry point as well. Titan would be neat, but it may not be as dynamic anymore. The moons of Uranus and Neptune would be fantastic. Triton would be the best one because we have seen active geysers since 1989 with Voyager. It'd be a cross between Enceladus and Triton if we really wanted a really cool ocean one. Europa would be up there as well too.
What is the last question on what is the trajectory to those two places, Triton and Enceladus and Europa? Time and route for those, and we got it after that.
Yeah, so getting to at least the Jupiter system would be about 4 to 5 years. It depends upon again your trajectory, your timing of where you want to be. Whether you use Venus as a slingshot could quicken your pace, but you're also going to need a way to slow down too. So there's your propulsion systems you would need to figure out. So 4 to 5 years, unless it's a very heavy rocket, then 6 years. To Jupiter, Saturn, you're looking at 7 years there, and then out to Triton, you're looking at closer to 9 years for 8 to 9 years for Triton. So, but again, it really does depend upon like aiming your shot, and if you're going to use a flyby of some sort. If you're going to use Venus as a slingshot, you could use Mars as a slingshot too. You're going to have to do it 2 or 3 times around Mars and then zip yourself out there. We have used Jupiter as a slingshot to go beyond Neptune before, so there's interesting paths and routes, and there's beautiful models and software out there that can help you out with that.
I was wondering also, this could be quite conclusionary, given that we've kind of all got recently worried about the IPCC report about the future of the planet and where we're going with global warming. In terms of the preservation of our intelligent civilization, if you look into the furthest future, it could well be about securing a place in space to be able to terraform and move to. So I'm wondering, what the potential would be of potentially, also just to say that it's not just a global warming thing, but we're talking the absolute far future. If we can get that far, is of course the expansion of the sun and the way that it will eventually envelop the Earth. We will get that global warming anyway. That will be something that couldn't be changed. Is it possible maybe to terraform some space on, say, an outlying moon of, say like Titan or somewhere to continue our species, or also much before this happens, just to to have somewhere to go if we need to, and things get worse here if they do.
So terraforming is more than likely not a good possibility. To terraform, you would need a nice strong magnetic field and an active core to generate that magnetic field, and then to keep up that atmosphere. Titan, unfortunately, is really cold, negative 300 degrees Fahrenheit, if that, on a summer day. So very, very cold. But terraforming Mars, it no longer really has that much of an active core. There's hardly any magnetic field left on Mars. It got destroyed. The moon does not have a magnetic field. So it's a matter of terraforming for habitability, probably not. But to have biodomes on, say, like the moon or Mars, that is a possibility. And that is being worked on by at least private companies as to what kind of materials could the biodomes be, and how would we sustain ourselves off of like the lunar soil and Mars soil, or can we bring our own fertilizer and everything. So that's an active research. But terraforming No, that is an incredibly big undertaking, because we would need to change the interior of your moon or planet to make the outside perfect for us. And oh goodness, we could barely, we could barely go to our own interior of the Earth. But changing at least the outside to help us survive, biodomes and tunnel systems, that is being worked on. Several international collaborations are currently working on that, especially tunnels. There's a really neat tunnel experiment going on in Finland, I believe.
Yeah, so though it's like the Earth, where it says you get a 1 degree warmer every, forget the exact amount, is it 25 to 40 feet or something? Be good to have researched that, wouldn't it? But in these very cold places in outer space, where to actually dig down a little bit, you could get, you could create the biodome on top, but you could also have the, a sort of underground sort of town city. I assume it's if we were in trouble on the Earth and it was runaway global warming, where we were on a Venus trajectory, because who knows? There are some that believe that Venus was like the Earth at one point. There are also some that believe that Mars was, but the planet was destroyed and changed into the environment we now know it as. I assume that with the 7.7 whatever it is now billion people, you couldn't be doing that. You're talking about a much smaller civilization, maybe, I don't know, not even a million, a few 100,000, a few thousand, because if you're talking about biodomes.
Exactly. But do we want to try? Yeah. But for the sake of science, yeah. Yeah, we do.
Well, it just seemed like a quite good conclusionary point to it all. And this is, you said, yes, biodomes. That's what we're looking at. That's what we've got to do. If you can't, either you fix it. The Earth is where it's at, though. Basically, if you can't fix it, you can't live with it, then it's game over until we evolve, as or already do, as intelligent life around another star. Which who knows if we've done that over and over again? Because if you go really deep. There are theories about how we came to come here. It's not necessarily what is possibly believed. We may have ourselves come from space, just as so much of the minerals, the materials that have actually like water and so on have actually potentially come from space. That could include us and life itself as well. It was sort of seeded, but there you go.
There you go. All right. Paul, do you have any updates on your end? What's going on there?
Yeah, I'd just like to say thank you, and we've done a great job here. It's been a lot of fun to chat with y'all, and we did capture the GSE being moved here to the site at the launch site. It is August 23rd, 2021. It's a Monday. Thank you all for watching, and we can wrap it up here. And I really appreciate you being willing to come on the show here at OceanCam and share your knowledge about space, different missions, and the current situation here in a different organization. So thank you, Dr. Caitlin, for coming on the show.
Thank you so much for having me on today, and hope everybody has a great rest of the week.
Yeah, and you can say anything you like. Also, Michael, thank you so much for coming on the show, and you did an awesome job. I really appreciate you coming on. I'd love to have either you and or Dr. Caitlin on again at some time, whatever's good for you. And I'll leave it to you to wrap it up, and I'll be here if you have any other questions. Thank you.
Great, yeah. Nice to meet you. Yes, we're still live, which means that it's still being sort of hosted. Yeah, you're incredibly knowledgeable, which is no wonder you call Dr. Caitlin Ahrens. It would be good. It'd be great to do another interview as well.
Yeah. Oh goodness, yes. Especially if there's any updates with planetary missions. Right now, there's a lot going on. So, like I said, Europa Clipper is well underway. Dragonfly instrument testing is underway right now, and a lot of lunar missions to look forward to. And Perseverance is doing some really cool drilling right now too. So in terms of planetary science, it's very busy, and it's going to be even busier coming up, at least in the 2030s. So keep looking up, everybody.
Well, it's good to hear something good actually about the 2020s and 30s, about something that's going to happen instead of oh no, it's going to be 2 degrees warmer by then or something like that. Which actually means I don't know if this is a good hypothesis. I know it's not exactly weighted across the Earth, but that means that if we've gone up by an average of 1.1 Celsius, is it, between now back to 1880, when they say the record sort of thing. Does that mean every temperature that you see, so I don't know if it's 20 degrees Celsius outside right now, is actually shifted up by 1.1, so on average, so every temperature should be 1.1 less within our atmosphere. That's just a way of looking at it I haven't really heard before.
Oh dear.
As a way of looking at that. So if you see 25, it should be 24. If you see 17, it should be 16, and so on. Yes.
Oh dear.
Because back in 1880 is where these records began, but and these were but we still had the variations. I assume that NASA does quite a bit of work with the climate as well.
Yes.
On what's going on with the Earth.
Yes, absolutely. So everyone kind of equates NASA with planetary missions, but yes, NASA has a fantastic large Earth branch as well, specifically with Earth observatories, along with the Venus mission selections with Veritas and Da Vinci. There's also been announced some new Earth observatories specifically for climate observatories. So those are going to be very exciting to launch. I personally don't know their launch dates because I'm only planetary, but yep, those are underway.
Yes. So yes,
right. Exciting times.
Okay, everybody. Good deal.
Yes.
Any last words? Either of you? Anybody?
Well,
all right. Well, thank you. Go ahead, Mike. You got something?
I think that was, I suppose that was kind of it, really. That it was good to have something that we're looking forward to that's happening when things seem a little bit apocalyptic at the moment, slightly, don't they? But it's all positive at NASA, which is, we're going to be doing these things and we're going to do it into the 2030s, and we've got all this planned, and it furthers our knowledge and our potential of possibly surviving outside of Earth, which I think is something that we do need to be looking at as well. Okay.
I'm gonna one last question. And then I'll ask, how can people get in touch with you? But the last question is, so we're here at SpaceX. Is there anything going on with NASA and SpaceX that we might look more into as an audience, or anything, insights, or anything that you have to say about SpaceX and NASA?
Yeah, so we're still trying to come up with different ways of how we can utilize with our strengths between NASA and SpaceX. It's still a very new friendship, partnership, in a sense, because we are going to be in the age of private space companies. And so figuring out each other's likes and dislikes and what's our strengths and weaknesses, and how we can better play with each other and collaborate better with each other is definitely an ongoing goal with NASA and certainly with SpaceX. So we are talking to each other, and it all comes down to just getting that initial idea and go, what if we did this? And so right now it just looks like a giant storyboard, if you will, of just different ideas and what if we did this and what if we did that, and SpaceX can do this and NASA can do that. That's where we're at right now with our very new-ish friendship collaboration. So something to look forward to as to what can we create together is right. Certainly going to be an interesting future.
Great. And then, so just how to get in touch with you, Dr. Caitlin, and Michael also. Go ahead. Thank you.
Yes.
Yes, so if you have any more space questions, you're welcome to Google my name and NASA, and my NASA email will pop up on Google. So you are free to email me.
Oh, that's good. Yes, well, you've been very good and knowledgeable on the show, Dr. Caitlin Ahrens. So if this was radio, there wouldn't be this picture, but anyone watching on YouTube, you have the name splashed up like one of those 24/7 news channels right there. And I guess I could ask Paul something just before it brings to a close then, which is what is going on today at your site there at I think I forget the name of it, Bacaccia?
Yeah, this is the SpaceX launch site, and so we're 2 miles away from the build site. So we're in South Texas here, right next to the ocean. And so this is the launch site. This is where they landed SN-15 for the first time, just to the left of the booster there, and in front of that black catch arm over here. So I'll change the layout here just real quick. Do it like this, and here we go. All right, just a minute. So just here, last thing on the screen, I have the umbrella here to keep the wind off the mic, but over there we have the black catch arm, and then we have booster 3, and then they moved that GSE tank in there over there, and you can see they're building the catch arm over there. So that black structure is going to be for the tower to the left. You can't see it right now. And so they're trying to finish the over-launch platform here and launch the first Starship. You can see it back there, Starship 20. And they're working on the heat tiles right now. And there is also a quick disconnect for the fuel back there, a yellow structure. So if you check out the channel here, I often do a lot of live streams about what's going on. I did a few this morning. And so you can, if you're not familiar with the site here, you can always check it out here. There's several other photographers that cover the site, like NASAspaceflight.com. There's Lab Padre. There's also Cosmic Perspective. And there's several different photographers that come through the site here. So a bunch of us cover the area here at SpaceX in South Texas.
That's what's going on. And now it's us too. Before it was it was Paul and me and not you. And now we've got this configuration now. So it's coming to an end. It is coming to an end now. And he was just describing what was going on at the site in Texas. Yeah, I suppose just before the end, how did you it might be a bit of a long story, but you can just make it like a short one, which is how did you first get involved in NASA? Because that is a job that so many people want to have, isn't it? Short of being an astronaut.
I'm back. Sorry about that.
Hi.
Back and you.
So we got a black screen there for a moment there, huh? Thank you for staying on. We'll close it up real nice then. Go ahead.
Yeah. So answering Michael's question really quick, it's all comes down to just having fun with different kinds of classes. Originally, I was a radio astronomer, and I ended up doing Mars Global Surveyor work for a period, and I never realized that planetary science was even a career option. And so working on Mars Global Surveyor really sparked my interest in planetary science, went to planetary conferences, built up a network, and just kind of flew right into Pluto and New Horizons for my PhD, and now I work mostly on the moon and working with the Lunar Reconnaissance Orbiter. So I bounce around the solar system quite a bit during my day job. And during the night, I'm an amateur astronomer. Get out the binoculars and look at star clusters and whatnot. So it started out as a hobby, and I did a lot of coursework for many years, and now I'm here.
And obviously, it takes that trajectory of years to get to there. Just as it does to become a doctor or a lawyer, I suppose, as well as. But that's it. Have you ever been asked by the mainstream media, to appear as a sort of an expert on documentary? These Discovery History Channel, I can call it that anymore, can you? The National Geographic and anything like that. Have you ever done that?
I have been asked once, and it didn't happen. But I would absolutely love to still do that. That is certainly on my bucket list. If I was ever asked.
Yes. Well, I think you'd be very good at doing that, to be honest. I really do.
Thank you.
And I'll just leave it to Paul now to close out this this Monday afternoon or Monday morning if you're over in the North America cast. And there he is, right at his site in Texas.
Yeah, I'm holding an umbrella too from this angle. The camera's coming out the front. Yeah, so thank you everybody for joining the stream. If you have any questions or you'd like to leave a comment, you can. We'll see it here in the chat, and either myself or Michael, potentially Dr. Ahrens, will talk about it potentially in the future. Who knows? But thank you so much for tuning in today. And again, this is SpaceX launch site in South Texas, and it's a great place to be if you ever have a time to come down and see a launch from South Padre Island. And Dr. Ahrens, thank you for coming on the show. And I'm going to rewatch this several times, and I'll get the info you gave about the different moons and do some more research. Thank you.
Thank you so much again for having me on today.
Great. And Michael, thank you so much also. You added a tremendous amount to this broadcast, and I hope if we ever do something in the future, if or when you're available, it'd be great to have you on also.
Well, thanks very much. Yeah, it's been very interesting because I'm really interested in all this, and therefore I was getting answers myself.
That's great.
Well,
Great. So, Michael, do you want to add anything about how to contact you in the future?
Yeah, well, how do you do that? Because it's like I'm not the most organized person. I mean, I'm going to have a shave sometime this week. You know what I mean? So, I would say, what is it? I use Adventures in Video with a number 1 at gmail.com. I guess I do have a Michael Farrie email. On Facebook as Michael Farrie as well. That's the station streams on channel 107 on the TuneIn app is the easiest way. Which is mainly all pop music at the moment, but we're planning the 107 stream to be like a Radio 4 sort of thing, and there is Michael Farrie interviews WordPress blog and Channel 107 Creams blog spot, which I just have all sorts going on in it, and you could probably send the message through that one, Adventures in Video 1 at gmail.com.
Okay, I'll put a bunch of these links in the description, both you, Dr. Ahrens, and Michael also. Great. So I'll let Dr. Ahrens close the show, and go ahead. You got it.
All right. Well, thank you again, everybody, for listening in. Thank you so much, Ocean Cam, for having me on today. And just truly keep looking up, and there's some exciting science to happen in a matter of years, even in a matter of months too. So stay tuned with more NASA news.
Okay, great. Thanks, everybody. We'll close it down in 5 seconds. Thank you, everybody, looking at the chat here. A lot of people saying goodbye. And 4, 3, 2.